Well, you could, but I don't want to.
Could it really?
Are there politics of math?
No.
You should be doing
What
the
theory
from
you
this.
like?
It wasn't Aristotle. It wasn't him.
Parentheses, not brackets.
Okay.
How to find the total area analytically?
Okay, so let me just summarize from the last class. We did the fundamental theorem of calculus. So this is where we did, I know it was a little confusing in the beginning. We will go over the homework after we finish with the lesson, okay? So I'm hoping that when you leave here today that you'll have all the homework done, and I'll give you the review in advance. Okay, so the first thing we did was the derivative of the antiderivative gets back what we started with, okay? And there are some cases where you have to apply the chain rule. So we did this example where it was like an x squared here, so we had to multiply by 2x at the end. We also did an example where we had to change the bounds, okay? And then the second page was actually review from the last section. This is where we actually have the bounds and we plug in the top, plug in the bottom, and subtract. Okay. So now, let's look at total area. So whenever I say just the integral of f of x dx, this gives us the area under the curve, but it's bounded by the x-axis. So basically when you have a graph, a curve, when you look at the integral, that integral essentially stops when you get to the x-axis, or when you say the area, like if I say y equals x squared, right, and I want to look at the area from 0 to 4 of x squared dx. So that's going to be this area. It stops when you get to the x-axis. But what happens when you have an integral of a curve that goes below the x-axis? What happens to that area? Or what happens to the integral? It ends up being negative. So what if we want to make that area positive? So here's an example where we want to find a total area, not necessarily just the integral. Because see, if I just did the integral from negative 2 to 2, this area where it goes below would count as a negative. But we don't want it to count as a negative. We want this to be positive, this to be positive, this to be positive. Okay, so there's two ways we could do this. One is just using the absolute value. Okay, you could do the absolute value of the whole thing or absolute value of the integral. So if I'm looking at the total region, you could just do from negative 2 to 2. And then you put the function, which is 3x squared minus 3 in absolute value, and then dx. But I want you to also be able to do this by hand. What were you going to ask, Luke?
Is that any different than just multiplying the original equation by negative 1 and then setting it at the zeros for your domain?
Say that again?
Oh, would that be any different than multiplying the original equation by negative 1? So it becomes above the curve and then just setting your domain on where it crosses the x-axis originally and then adding that to the first integral.
I don't completely, I'm trying to visualize what you're saying. Like multiplying it by negative 1, the whole thing, or just the part that goes below?
The original equation, so that any value underneath the x-axis, which is negative, would be multiplied by negative 1 and would become positive, which is essentially the
Yeah,
absolute
but multiplying it by negative 1 isn't going to automatically, that won't quite work. I have to think a little bit more about that, but multiplying there. Let me just give you this example. So one way to do it would be to look at just taking this graph, and if you you graph the absolute value of that function, it's just gonna flip everything that goes below the x-axis, it's gonna make everything above the x-axis. So I could do second trace, and then I could do number 7. The lower limit is -2. The upper limit is 2. And then it's gonna shade it in. And of course, because this is now above the x-axis, it stays as a positive. So we get 12.
So what is this to solve for? The area of the total function?
Yeah, it's the area between, says here, find total area of the region between the curve and the x-axis. So in other words, I need, the whole point to this is that taking this,
I don't even get what's going on right now.
we want this to be positive.
Oh, because it's the total.
So like this
area.
is already positive and this is positive, but this is gonna be negative because it goes below the x-axis. You guys just had a quiz where you did this, but it wasn't, you just did it with like triangles, remember?
You just have to add them both up.
Okay, so how would we set this up? So another way you could set this up to find the area is, I'm just gonna tell you, this intersects at -1 and 1. So if we did from -2 to 1, sorry, -2 to -1 of 3x squared minus 3 dx. But then what would we do for the next part? From -1 to +1. What's gonna happen with this graph? Notice I put a minus sign here instead of a plus. Why would I do that? That's one way to look at it. Why would I subtract the area under the curve?
It's gonna be a negative number.
Right, so this is gonna be a negative number.
Oh.
So if I end up subtracting it, it's gonna end up adding.
And then you
And then I have one more integral from 1 to 2.
Okay. Up.
So I basically look at this as gonna be a negative. So if I subtract a negative, it becomes plus a positive, that's all. These should all be positive, plus a positive, plus a positive. There shouldn't be any negative areas, essentially. That's all. So if you were going to do this by hand, and you ended up with a negative number, just make it positive, because you're talking about total area. No?
Why is the first option, the first way to do it, why would that be the right answer rather than being messed up because of the negative?
So this would be if you can use your calculator.
Oh, okay. And so if not.
And then this is by hand.
Okay.
So I'm just trying to show you that there may be a case where you can't use your calculator, and most often I'm gonna let you use your calculator to check all your answers anyway, but for this one, like what you would basically do, so let me just continue. So my area would be, what would this be when I integrate? This would become 3x to the third over 3, so it'd be x cubed. Minus 3x. So you would want to evaluate this from -2 to -1. And then you're going to end up subtracting, oops, the same thing.
So that becomes 0. Oh, no, it doesn't, because.
And then ending up adding.
I don't understand what you did there.
You don't understand where I did where?
The last step, you did
This
that
one?
over?
Yeah.
Okay.
Well, all of these have the same integrand, right? So take 3x squared, find the integral of that. What's 3x to the third over 3? The 3's cancel, I get x cubed. Then what? Minus 3x. So basically, you have the same integrand, it's just that you have it broken up into 3 different parts.
Yeah.
Okay? From here, you could plug in to the top and to the bottom, and then, just to save time, you do get 12.
Oh, so my method works. That worked.
You did try it? Okay.
When
I didn't quite understand, so.
When are you available to? Wait, can you do that?
Andrew, what did all last time?
Okay.
So, again, for the area, if you want to just go to math and then 9, 9. You just plug everything in. So notice this is what it looks like, those of you that have the TI-83. But otherwise, you just type it in as you see it. So it's from -2 to 2. And then you put the absolute value around the function. And then dx. And that is equal to 12. So we just... So guys, you can either do what I did, where you can type it into your y equals and do it that way, or you can do the math button. Number 9 is the function integrate, and you get the absolute value by going math over to number. Right, if you don't put the absolute value,
Why didn't you just get an 84?
okay? Everybody get 12?
Can you scroll up a little? How'd you get 12 from 5?
Oh, I didn't do all the work here, but basically if you plug in negative, so it'd be -1 cubed minus 3 times -1 minus the -2 cubed, like, it's a lot of computation.
Yeah. So you just plug it in for that.
Okay.
Wait, hold on.
Oh. Okay, guys, so. Oops, wrong class. Okay, so this is going, I'm going to help you guys go through these homework problems because I'm not going to be here on Tuesday, and then I'll give you the practice test, okay? All right, we're finding dy dx, which means we're finding the derivative of the antiderivative. So basically, you're just looking for, you're going to replace, okay, wait, actually, let me rewrite this. So there's 3 things that we have to do. 1, make sure the upper bound has the variable, and the lower bound is a constant. So this should be a constant here, and the upper bound should be the variable. That's the first thing we want to make sure. Okay. Then step 2 is we're going to take whatever the variable is, and we're going to substitute that in for t. And then the last thing is apply the chain rule if necessary. Okay. No, we do not. Guys, we are doing d dx of this. This is really easy. So, first thing we've checked for is the lower bound a constant. Yes. Does the upper bound have the variable? Yes. So I'm basically going to take my integrand, which is sine squared of t. So that's going to become sine squared of x. And do we have to apply the chain rule? No. In fact, you can see the answer. It's right above there. Try to ignore. I couldn't copy. It was a little awkward trying to copy and paste without the answers. So, okay, next one. Is the lower bound a constant? Yes. Is the upper bound a variable? Do I have to apply the chain rule?
Yes.
No.
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 No. So it's just, so d dx of the integral from 0 to x of t to the 3rd minus t all to the 5th just becomes x cubed minus x to the 5th. Next. Okay, so far everything's pretty basic, right? So the next one, here's number 5, so dy dx, I'll just write dy dx, basically just becomes tangent to the 3rd of x.
Wait, that's just that easy?
It's that easy.
What about the 2 part?
It goes away because the lower bound is constant, so if we were doing the derivative of the antiderivative, basically that lower bound just goes away because when we end up doing the derivative of that, it becomes 0. What's the next one is also 1 plus x.
So 9's where it gets complicated,
Right, now, number 9.
So 7 disappears.
The 7 just disappears. Now, The next one, the lower bound is a constant, so that's good. The upper bound has a variable, however, it's no longer just x, it's x squared. So we have to apply chain rule. So it's dy dx. So we're going to take this, it becomes e to the x squared times, what's the derivative of x squared? So the whole thing becomes 2x e x to the fourth. That's how you do it. Okay, so e to the t squared becomes e to the x squared times 2x, because we have to apply the chain rule. Okay. Next one. Okay, the lower bound is 2, the upper bound has the variable, but it has a 5x, not just an x. So I'm going to take 5x, and everywhere I see a u, I'm going to replace it with a 5x.
And then you times it by 5.
Correct. So I have square root of 1 plus 5x squared all over 5x times 5. And then what happens here?
Why you want to find the chain rule?
Right, chain rule, the 5's cancel. So I get square root of 1 plus 25x squared over x. Question? We're okay with
So basically you
So before we do anything, we have to switch this to a negative, move the 6 here, x here. I haven't done the derivative yet, so now when I do dy dx, I'm going to have ln, actually a negative ln because I have that negative in front, and then it's going to become 1 plus x squared, and do I have to apply the chain rule?
Yes.
No, just, well, what's the derivative of x? 1, so you can multiply by 1.
I keep forgetting that you don't.
Exactly. You could apply the chain rule every single time if you want to be on the safe side.
The ln 1.
No, it's derivative of the top bound. We are going in order. So here they get more complicated. Okay, so first, pretend you can't see the answers. So before you do anything, switch this around so that the x to the third is on the top and the 5's on the bottom. Yes, there still is.
People aren't doing it right now. I'm looking at you.
So dy dx is what?
Thank God.
Cosine, actually negative cosine, of x to the third over x to the third squared plus 2, and then the whole thing gets multiplied by 3x squared, which is the derivative of x to the third. So there's not a whole lot we can do with that. It's just going to be negative 3x squared cosine of x cubed all over x to the 6 plus 2.
You don't want to do that.
Let me know when you're ready to move on.
I'm trying with that.
Oh man, we have to do it again.
We have to do that again. So we're going to switch it, make it negative, move the 0. Actually, let me write square root of x as x to the 1/2. Okay, so it's become negative sine x to the 1/2 squared times what's x to the 1/2, the derivative of that's going to be 1/2 x to the negative 1/2. So it's going to become negative sine of just x all over 2 root x, because the 1/2, the 2 will go to the bottom, x to the negative 1/2 is really a square root of x in the denominator, and that's pretty much all we can do with that.
We can do this in our, we have to.
No. Okay, the last one on this page, number 19.
counting down the days until I'm operating in class.
That would
Yeah,
have.
so it's not- no, me too.
Your favorite movie now?
I have no idea how many days you have left. I'm not counting down the days. Okay, so notice here, both of our bounds have variables in. So basically what I'm gonna do is I'm gonna go from x squared to 0 of cosine of 2t dt. And I'm gonna use my additivity property and take it from 0 to x to the third of cosine of 2t
Why do we
dt.
use zero?
You can use any constant that you want.
Like,
You
use, like,
you can
9.
use 9, you can use pi, you can use a million. We just use 0 because it's probably the easiest one just to write. You put 1. Maybe 1's easier. You could use e.
What about I?
Seriously?
I'm not using
Now, before we do this is, what do we need to do? The first one has to get switched around to make it negative. So it's negative from 0 to x squared of cosine of 2t dt plus 0 to x to the third cosine of 2t dt. Now go ahead and apply the rules. So if we want to do the derivative of all of this, what's that look like?
Negative cosine.
Okay, so negative cosine of 2x squared times, how about times 2x? Remember, it's just the derivative of the upper bound. Plus, now it's going to become cosine of 2x cubed times, what's the derivative of x cubed? 3x squared. You're not doing the derivative of the 2t inside, you're just doing the derivative of the top part.
I made a dumb mistake. I'm really sorry.
So you get negative 2x cosine of 2x squared plus 3x squared cosine of 2x to the third. And that whole thing is, you really don't want to try to, don't worry about trying to factor out x's or anything like that, just leave it.
You can turn off the screen capture, please.
So for the next set, we're going to, this is what we've done before. Now we're actually doing the antiderivative. So what is the antiderivative of 2? It's 2x. What's the antiderivative for 1 over x? It's natural log of the absolute value of x. Now we want to evaluate this from 1/2 to 3. What that means is we're going to plug 3 in, and then we're going to subtract plugging in 1/2 in. And I know. So it's going to be like this. What's that? Do we have to use the domain?
You have to include what will satisfy the domain.
In this case, actually, you don't need to use absolute value because you could see that what you're plugging in is positive. So don't worry about it. So 2 times 3 minus ln of 3. And then we want to subtract 2 times 1/2 minus ln of 1/2. Okay. Just for something like this, just do you can do the decimal approximation. I could show you, they use properties of logarithms. That's all. If you want me to show you, I can. So we should get about 3.208. You would be able to use your calculators. I could show you how they got the 5 minus ln 6, but it's just using property of logarithms. Let's look at the next one. So this one. Okay, what's the antiderivative for x squared?
No. 3x to the third over 3.
Okay, so it's going to be x to the third over 3 plus, this is x to the 1/2, so it becomes x to the 3/2 over 3/2, or 2/3 x to the 3/2. So plug in from 0 to 1. Now the nice thing in this one, when I plug in 1, I just get 1/3 plus 2/3.
Can you, I'm a little bit confused.
You're confused on how I got x to the third over 3 or the 2/3 x to the 3/2. Okay, so if I have x to the 1/2. If I add 1 to that, it becomes 3/2. But then I have to divide by that new power.
Oh.
And that, dividing by 3/2 is the same thing as multiplying by the reciprocal. Okay? And then what, you heard what I was saying, when you plug in zeros, this just becomes 0.
Yeah. So it's always the top one minus the bottom one?
Yep.
So how can you, oh,
Okay,
the
so-
minus 0 doesn't matter.
Let's look at 31. So if we have negative 6/5, what would that become?
It becomes negative 1/5.
So x to the negative 1/5 over negative 1/5.
Negative 5 x
So it's really what? Negative 5 over the 5th root of x, evaluated from 1 to 32. So it's negative 5 over 2 minus negative 5 over 1. So it becomes plus 5, so we get a positive 5/2. Question. Yeah, because you end up right here, minus negative, so 5 minus 5/2, basically. Next one, what's the antiderivative for sine? Negative cosine, good. So negative cosine of x, evaluated from 0 to pi. It is. So it's negative cosine of pi minus negative cosine of 0. So I'll try.
Because it's hard to just write down in
We
this.
have 1, we have 1, positive 1.
Good. So this is negative 1. And then this becomes plus. Well, remember, cosine of pi is negative 1, and cosine of 0 is positive 1. So when you plug in, you end up with a positive 1 plus a 1, which gives us 2. Much better. All right, what's the antiderivative for secant squared? Now, what derivative will give us secant squared? Tangent. So it's 2 tangent of theta, evaluated from 0 to pi over 3. If it was just tangent, no, we don't have a formula for those. Not yet. We'll learn substitution in the next chapter. Okay, so I have 2 tangent of pi over 3 minus 2 tangent of 0. What's tangent of pi over 3? Just for 3. And that's 0. Let's skip this because I told you guys, don't worry about 37. Skip 37 since that was one of the formulas I said you don't need to know at this point. Now, for 39, 39 wasn't on? Perfect. Here we go.
I forgot, is tan equal to sine over cos or cos?
Sine over cos. Okay, find the total region between the curve and the x-axis. So take a graph 2 minus x. What's that look like? It's negative x plus 2. No, because what do we notice about the region? Well, you could just figure it out by hand, by just finding the area of the triangles. Or you could break it up into 2 different integrals. Do you see that? I honestly think it would just be easier just to use the triangles. Because this triangle has an area of 1/2 base times height, 2 times 2, so that gives us an area of 2. And this triangle has the area of 1/2, 1 times 1, which is 1/2. So add them together, and you get your 5/2, or 2.5. Do you see that? If you graphed it accurately, you would see that your two triangles, just, it works out that way.
We do 1/2 base times height.
Yep. Okay. Find the area of the shaded region. So this area, we're going to break up into two parts. One part's going to go from 0 to 1 of x squared. But then here, this is the integral from 1 to 2 of 2 minus x dx. See, do you see how like one curve is bounded on top on one? It's like you have to divide it up into two separate parts, because one is going to be the integral of x squared, and the other one's going to be the integral of 2 minus x. So what's the antiderivative for x squared? It's x to the third over 3, evaluated from 0 to 1. And what's this one? This one's going to be 2x minus x squared over 2, evaluated from 1 to 2. So what do we get?
Really, two sides of the equation were not that weird.
Oh, then maybe.
Without it, they're not that weird. Exactly what I mean, yes, it's no, what's the other?
Sorry, I didn't feel like, yeah, it's a 2 squared. A 1 squared. So remember, you're only plugging in, so if you plug in 1 here, you get 1/3. Plug in 0, that's going to be minus 0. Plug in 2, you get, what, 4 minus, you get 2 for this part. Plug in 1, you get, 3 halves?
No, 1/2.
1/2. 2 minus 1/2.
You got 1/2.
2 minus 1/2.
No, you're 1/2. I mean, sorry, 3/2. Yeah. And these are some loads that like the high road. Wait, how's that? 5, 6 in this thing. 1/3. Oh, I see.
Okay, this is kind of reverse area. Picture that if you took this entire rectangle, what's the area of the rectangle? Good, 2 times pi. And if I subtract the area under the curve, I'll be left with the shaded region. So I'm going to subtract the integral from 0 to pi of 1 plus cosine x dx. Sure. Just remember, how do you check your answer? Take the derivative of x plus sine x, and you should get back what you have inside. Do the derivative of this. If you're not sure about sine, if it's the derivative of x, it's 1. If it's the derivative of sine, positive. That's just a quick way you can check.
The derivative of regular cosine x
Say that again?
Did you get rid of protracted memory? You're too smart. Is it right?
No, it's not, it's a scientific one.
This class is reserved for people who can't speak or anyone with I'll put it as a compliment.
Yeah, no, I'm sorry.